Okay, you guys, good morning, good day. This one is going to be dealing with complex numbers. We're going to do this before we actually solve anymore because we might have issues or problems that involve these type of numbers. So what we're going to be working with, ladies, today and gentlemen, is we're going to be working with what's called complex numbers. To be quite honest with you, you have never seen this. This should be probably the first time you guys have seen it. So if you have any questions, please feel free to contact me. Okay. So the warm-up real quick asks you to determine the number of types of solutions that you might have given a graph. Just be honest with yourself. Pause the video and see if you can answer it yourself. Okay. So for the first one, you should have answered 2 real solutions. Now, why was it 2 real? Due to the fact that it touches the x-axis twice, this one and this one. So whenever a graph touches these x-axis, these are considered solutions, and in this case real solutions because they actually land on the x-axis. Please remember that intercepts are also called zeros, they're called solutions, and they're called roots. So they have different names, but they all stand for the same thing. The second one, you should have answered with 1 real solution. Again, because it touches the x-axis at one point, and that would be considered the solution. Now, if you look at the third one, it does not seem to intersect the x-axis, but the function can still exist. It so happens that this function is x squared minus 1, which will happen. The only thing is, because it doesn't land on the x-axis, it's considered to have no real solutions. What kind of solutions will it have? It'll have what's called complex or non-real. Okay, so this is just kind of like a precursor of what we're going to be doing. Now, what's the main idea that I want you to come off with this lesson is this: the imaginary unit. It's a number that has appeared in the past when they've done some calculations. I is used to signify the square root of -1. If you were to push this in the calculator, or let me just show you right now, if you were to type it in, you're going to get error. Why? Because it doesn't exist in the real number system. Okay, so I stands for the square root of -1. Before we move forward, what I want us to do is practice learning how to simplify. Okay, now when it comes to simplifying these type of numbers, what you're trying to do is avoid to have any negative number inside the radical. So what are we going to do? We're going to do something in an extension that we did last week, which was simplifying them. We're going to break it down to 2 numbers, preferably one that might be squared. So in this case, we have 9 times 2. Well, that would give us positive, but we want negative. So we put the 9, or designate 9 as to be negative. Does it really matter? No. What matters now is we're going to go down the list of factors and see which one has a perfect square. What is the square root of 9? It is 3. Let's cross it off to remind myself. 2 doesn't have a square root, so it would stay under the radicand. But this negative number, remember, we don't want to write it. So what we're going to do is designate the I. If you notice, it follows the 3, and this is how you're supposed to write complex numbers. Let's look at this one again. What can give you 12? 2 and 6, or we could use -4 times 3. Again, you're looking for factors. Your goal is to always try to find a factor where it's a squared. Again, 4 has a square root of 2. Cross it out. 3 doesn't have one, so I leave it alone. But there's a negative that exists, so I put I, radical 3, and I am done. So, what we're doing right now again is practicing how the imaginary unit is being used and how to interpret it. Let's look at C. 25. So happens that it's a squared number. What's the square root of it? In this case, 5. Square root of 25 is 5. But because it's negative, we're going to put the I afterwards. And that's it. So, with this example, it's illustrating. If it has a square root, cool, even better. Find that root, rewrite it, and this time you're going to eliminate the negative by writing the I. Last one is D. D has the square root of -7. We all know that 7 doesn't have a square root, so it would remain under the radical. But again, we don't want it to look like this, so what we're going to do is put it in front. So this example is letting you know, if you have a radical, it never follows, the I never follows. It's always ahead of it. I is always ahead or in front of the radical sign. It's never afterward, okay? So we just practiced learning how it's supposed to look like. Now we're going to learn what's called an imaginary number. You're like, what's the difference? In this case, it has 2 components. What are the 2 components? The first one deals with the real number system, and the second one is the imaginary number system. And something else that is very important that I need to mention is this format is referred to as the standard form. I'll move my hand in a minute, but it's called standard form. So whenever they ask you to write it in standard form, that is what they're referring to. You separate the real from the imaginary. Okay. So we've practiced writing them, comprehending them, understanding what a complex is made up of. Now the second example, we're going to practice what's called graphing. And don't worry, the graphing in this part is actually pretty simple. Okay? It's not as complicated as you may think. It still has a coordinate plane, but instead of calling it a coordinate plane, we're going to call it a complex plane. Why is it called complex? Because now the y-axis is no longer the y-axis. Now it's called the imaginary axis. So the vertical now is considered imaginary, and the horizontal version still remains as x, but this time we're going to call it the real axis. It'll make sense once we practice graphing it. Okay? So, imaginary is your y-axis or your vertical. Real axis is your horizontal. Vertical is your imaginary. Horizontal is your real. So let's practice graphing some. Okay. So the way you're supposed to read it is this. You want to identify what part is the real, what part is the imaginary. Real is the one without the variable. In this case, it'll be -5. That's my real. So what does that mean 3i is? That's your imaginary. So what you do is, where does -5 exist on the real axis? Real axis, -5 would be here on the left. Where would number 3 be in the imaginary? It's positive, so I would go up 3. So 5 over 1, 5, 1, 2, and there's your answer. You might be saying, is that it? Yes. It turns out that when you graph a complex number, you're really not graphing it per se. What you're doing is just plotting a point. So the graph of a complex number is a point. And that's it. Let's try again. We have 4, negative 2. So we're going to go 4 to the right, down 2. And we're done. With C, it's 7. It's telling me that my real part is 7. If you notice, there's no I, which means there's no imaginary component. So we're done. And the last one, if you notice, it's negative 5i. So that means it's on the imaginary axis down below. And we're done. So this one would have been 4, negative 2. This one would have been 7, 0. And this one would have been 0, negative 5. So plotting complex numbers is not as difficult as it may sound. All it is, you're going along this time the imaginary and the real axis. Again, real is horizontal, imaginary is vertical, and you're at the end of the day, all you're going to do is plot a point. Okay? Now I'm going to do the notes a little different, only because I really want to make sure you understand. So what I want you guys to do is, after you write and highlight what I want you to highlight, I want you guys to watch the Ed puzzle called Adding or Subtracting Complex Numbers. Once you watch that video, go ahead and try these and compare the answers on Schoology. Okay? I will post the notes as well. Okay? So basically though, when it comes to adding or subtracting complex numbers, all you have to do is combine like terms. What do we mean by that? Real goes with real. Imaginary goes with imaginary. Okay, another thing, sometimes they won't tell you straight out that you're going to add, so you have to look at it. The parentheses here are separated by a plus, so that means you're adding them. The parentheses here are separated with a minus, so you're going to subtract. So if you notice, they'll say simplify, and then they say to write it in standard form. Again, standard form means A plus BI. So at the moment, go ahead, pause the video, go to Schoology, and then watch the Ed puzzle called Adding or Subtracting. And then what I would like for you guys to do is try these 4 on your own and then verify your answers. Okay? So go ahead and pause. All right, you should have watched the video, try to have answered the questions. And at this moment, I want you guys to verify your answers. Also, make sure you show work. These are your notes, and you need to understand them. So if you have any questions, always feel free to ask. So you learned how to add or subtract. The next thing or next type of operations would be multiplying and dividing. In this case, we need to remember something very, very, very important with the complex numbers, and that's I squared. Whenever you see I squared, it really represents -1. Okay, so this is how it works. Because, you know, math people are a little special and they want things a certain way. So you have 6i squared. How should you mentally interpret this? It's saying 6 times negative 1. So in reality, 6i squared is really negative 6. And you're done. Okay, let's do it again. You have negative 5i squared. Again, mentally you should visualize negative 5 with negative 1, which ends up giving you positive 5. If you take a second to look, what does it do to the coefficient? It changes it to its opposite. So I squared changes the coefficient to its opposite. If it was negative, it becomes positive, and if it was positive, becomes negative. Okay? Okay, so what I would do is make sure to write what I'm going to show you right now, then pause the video and watch how to multiply complex numbers. But before you do that, what I want you guys to do is to write this part down. Again, notice it's telling you to simplify. It doesn't say to multiply or divide and all that stuff, so it's up to you. And again, it wants you to put it in standard form. Okay? So, write this down, pause the video, watch the Edpuzzle, and then practice again. So, the first thing you always want to remember to do is distribute the terms using like the FOIL method. 2, you want to simplify by combining like terms like we did in the previous example. Oh, and by the way, I just realized that this is example 4. Combining like terms. And then the most important thing is if there is an I squared, you are to change the coefficient. So in other words, it disappears. All right, so go ahead, pause this video, and what you should do now is watch the Edpuzzle. Once you've done it, try your best with these 4 examples and check your answers. What are the answers? For the first one, you should have arrived to negative 6 minus 15i. The second one, you should have arrived with 2 minus 11i. The third one, you should have gotten to 23 minus 2i. And lastly, letter D, you should have arrived to negative 21. Alrighty, double check your work. Make sure you've done it correctly. Question it to see what is it where your error was. And again, I will be available for tutoring. Alright, last operation that we got to work for. And that would be dividing. Okay, dividing is kind of misleading. Why? Because we technically don't divide. So at this moment, what I would like for you guys to do again is pause this video, watch the Edpuzzle called Dividing Complex Numbers. Once you do that, try your luck and try these 2 and compare your answers. Once you've done that, you can go ahead and start your homework. Okay, you should have already watched that video of dividing complex numbers. What you need to get out of that is you need to multiply by the conjugate. of the denominator. And just like in the video, it does that way to have no longer an I. Friendly reminder, what's a conjugate? If your number looks like this, a plus bi, the conjugate would be a minus bi. Okay, so go ahead, try A and B. This would be examples 5. Try your best and see what happens. Okay, you should have tried. Your answer should have been 7 over 25 minus 26 over 25i. The last one should have been negative 1 over 6 minus 2 over 3i. These should be the answers, but I need to mention one thing. When it comes to B, the most common answer I do get is negative 6 over 36 minus 24 over 36. This is considered wrong. Why? Because you need to simplify. So, if you at least got to this point, that means you're on the right track. The only thing is now you just got to be mindful that you're dealing with fractions. Therefore, you need to simplify when it's possible. So the real answer is the one up here. All right, you guys, I hope this helped. If not, let me know. I will be here for tutoring. You have a good day.